All right. It really feels to me like I've already lectured on the idea of modulus and division and things like that. And you've also have supposedly taken fundamentals and know what modulus is. Have I done modulus?
Yes.
All right, good. Integer division then is the last thing that I want to hammer in yet again. If I do this, x is equal to 10 divided by 3. Those are both integers. So it's going to round it down. So the division operator, if both operands are ints, the result is an int. It doesn't matter what's on this side. That could be a float, a double, a long, whatever this was. This expression right here produces an int because both of them are ints. The same is true if they are variables. I see you raising your hand. Just a sec. Let me type in 4 things. Then I'll ask. So if I did that, a is equal to 3, b is equal to 2, float c is equal to a divided by b. You ignore this part at first. You're dividing an int by an integer, so it's going to round down. 3 divided by 2 is 1.5, rounded down is 1. So float would be equal to 1, or more precisely 1.0 by the time. Yes, sir?
Okay, I'll let you know we've already done this.
We've already done all this, figuring that. However, when I opened up the PowerPoint, it took me to that slide. Have we already finished this chapter?
Yes.
Alrighty, good. Don't let me ever lecture on a chapter. We don't have the time for that, especially when we've missed a week. We've done constants. Yeah, we are done with that chapter. Thank you. Okay. Just think of how well you've learned that stuff, though. Okay. Something I actually do want to talk about that they didn't talk about there is rounding errors, for one thing. Let me give you a demonstration of a rounding error, a floating point rounding error. Come on. I just want the shortest possible one. If I don't find it in the next 45 seconds, forget it. Okay. Still worthy of a topic. If you do some math and you're using floating point values rather than integers, integer math is precise. It's 100% precise until it hits an error, and then, you know, it's all bets are off. Like if the number gets too large to be held into an int and you get overflow, then you have no idea what that is. But otherwise, you know, you always know that 1 plus 1 plus 1 is equal to, 3. However, if you're doing accumulation of values with floating point numbers, sometimes you'll get surprised and see that it's off. It'll say like 4.0000001. Actually, I can think of one that'll probably do it. What if we do 1 divided by 3 times 3? Or 1 divided by 3 plus 1 divided by 3 plus 1 divided by 3. We would think that that's going to equal 1. Let's find out what that actually equals. So, I don't care if you follow this part yourself. If you feel like it, great. Because the rounding error leads us to another topic. How do you compare two floating point numbers that may not be precisely the same? Remember, floating point numbers, can be as precise as like point followed by 300 zeros and then a 1. If you do a double, they go out to that precision, or 270 zeros. I forget what it is. So when you're comparing two floating point numbers, there's a very real, if you're trying to do equal and you're comparing two numbers, there's a good chance that they're not going to be equal. They're just going to be approximately equal. And so we need to be able to handle that. the usual. Okay, so I'm going to define three floats. Float A is equal to 1.0 divided by 3.0. The reason I didn't do 1 divided by 3 is what is 1 divided by 3 in this language if they're both ints? 0, exactly. Unlike Python. Python doesn't round down like that. Float B is equal to the same thing. I could just set it equal to A. Float C is equal to A. Float D is equal to A plus B plus C. And let's print D now. Except there's no print statement. C out, D, E and DL. C out is undefined because I forgot to do the using namespace up at the top. I'm going to be all program. Nah, I'm going to wimp out. Doing using namespace std is wimping out. It's unprofessional. What we should be doing is going and leaving that out and prefixing all of our things with std : : And the reason for that is the standard namespace has a whole bunch of stuff in it besides cout and E and DL and stuff like that. And you don't necessarily want to bring in the entirety of that namespace into your code. So whenever you post examples of code online or you look up code online, they're going to be using std : : and they're not going to be using namespace. Okay, so let's run that. Let's see if that demonstrates what I'm hoping to see, which is a rounding error. Why is it going to be a rounding error? Because 1 divided by 3 is not a precise number. Okay, fine. Prove me wrong. What if I change all these floats to doubles? I'm not going to belabor the point if this doesn't do it. Nope. Okay, fine. Sorry. I'll have a better example of that. What if you wanted to compare two floating point values? What if B equaled 0.301 and C equaled 0.3124 or 3.0125, like that? You're doing two temperature readings, right? You call your sensor twice, it returns two temperature values. And, no machine, like that is going to return exact values unless it's programmed to do so, because data is not in the real world is not precisely quantized, right? So how do we do this? If B is equal to C, right? We can't do that if we are not sure that they're going to be returned, that the value could be too varied, that they could differ by small amounts, as in this case. Maybe those are close enough, right? Maybe we only care about 2 digits of precision. Maybe we would want these to be considered the same. What you do is you have to calculate a delta, a difference between the two, and then compare that delta against an acceptable error. So that would only trigger if those numbers were exact. If you're doing a math on floating point numbers, you're multiplying and adding them and stuff like that, it's likely that if you have a rounding error introduced or something slightly different, that they're not going to be the exact. So what you do in that case is you take the difference between the two, and then you take the absolute value of that. If you've taken a chemistry or physics course, you're already familiar with the idea of a delta. It's just a difference between two measurements. So double delta is equal to B minus C, but we want to take the absolute value of that. My brain is broken. Can I just use ABS or do I have to use math.abs? Okay, absolute value, C++. All right. It's just ABS. Overloaded in C math for floating point types. Okay. So I need to add and include up at the top. Microsoft's libraries are a little bit different than the ANSI standard, even though they shouldn't be. So this might not be strictly necessary. So I went up to the top and I added include CMath. And I think at a certain point, I said you don't have to type this, and then all of a sudden I started typing stuff that I'm expecting you to type. So if you did not type this in, that's okay, but take notes because this is an important concept. Okay, so the delta is equal to the absolute value of B divided by C. Just as a test, I'm going to print that out. Yeah, okay. So now we have the difference between the two. If the difference is 0, they are exactly the same. So if we wanted a precise match, well, if we wanted a precise match, we just would have written it like that. But if we wanted a precise match, we would do this. If delta is equal to 0, they are exactly the same. If the delta is less than a certain error threshold, I hate the word threshold because sometimes I type 2 H's, sometimes I don't. I haven't defined the threshold yet, so that's giving me an error message. Let's do that up above. Double threshold is equal to 0.001. Or maybe just 0.01. There we go. So if delta is less than the threshold, we're going to print out close enough. And in this case, it will be, if I recall my data. Maybe not. Find out. Okay, so they are. That makes sense. Whenever you do comparison of two floating point values, if you're checking for equality, you don't just want to do equal, equal to see if those two values are 0. Instead, you want to set up a threshold and a delta. So I hear people typing. I may have gone too fast. Anybody getting syntax errors that you'd like a correction on? Yeah. If you get my card, you want this. Okay, you left the same thing out I did. Using namespace STD. So right above that inline. Yep, using namespace STD. And just missing the letter A. Double space A equals variable name. Anybody else? No. You don't have to type this in because I know that I said at the beginning of this. I don't know the lines, so that's better. Another one. I'm not spotting it yet.
It says no such directory up here.
Okay, CMath without the X. Yeah, there we go. Maybe that'll correct once we start recompiling.
Whoops. It's not.
Is he?
Oh, no.
Oh, semicolon after. You're kind of doing
I was supposed this time is
Okay, good deal. All right. So if you didn't type in the rest of the code, go ahead and make a new project and put in your boilerplate, okay? Just so that you're ready for the next batch. Hopefully by now you know what the boilerplate is. It's the IO stream, maybe string, using namespace, int main, right? Everybody should probably actually have the boilerplate saved as a text file so that they can summon it up really quickly. So yes, you can group your math with parentheses. 10 divided by 5 minus 3. What do you do first? 5 minus 3 is 2. And then 10 divided by 2 is 5. Algebraic expressions. This is more fundamentals of programming. If I tell you to write an expression that looks like this, and so I ask you to program that, except I tell you to use the letters pi rather than the symbol pi. So the question might look like this. You notice that math books tend to leave out the multiplication symbol when they can get away with it. Whatever. You know that's supposed to be a squared. So we go, okay, well, we really need that to be pi. That's not going to work. How about if I said this? A is 4 divided by 3, 2 plus 1. That's perfectly good textbook formulas, but it's not going to work in any programming language. What do you have to do to fix that?
Multiplication symbol.
Yeah, you have to put a multiplication symbol right there. Also, you probably had better change one of these to floating point values unless you really want 4 divided by 3 to round down by 1. But anyways, there is no implicit, there's no implied multipliers. So whenever you're turning something into an algebraic expression out of a book or off the internet into code, make sure you don't leave off the multiplication symbol. And I'm sure I have a question like that in the exam. So this has to really be expressed as A equals pi times R, or A is equal to pi times the power of R to the second power. Hopefully with semicolons at the end. And y'all could use the equation editor in Word to make it look prettier, you know, with the big old divided by 3 line underneath it, just to prove the point. Oh, come on. All right, if I ask you to turn that algebraic expression into programming, assuming all the variables are already declared, what would it need to be? There's more than one way to write it, but let's give it a shot. A is equal to what? B times, parentheses would be a good idea. In this case, we could give it away without the parentheses, but it's a bad idea. So A times A divided by B, or A, you know, POWA to the square. You could divide it by 3 out here, you know. You could divide it by 3 in here. When it's really important to use parentheses for grouping is if the bottom, the denominator, has more than one part of its expression, like that. Then you absolutely have to enclose the 3 plus x in parentheses. I'm getting tired of typing the POW function, so I'm taking that one out. All right. So then, somebody read this one off. A is equal to B times, yeah, I could use parentheses. I could also leave them out. I think I'm going to leave them out just so that I don't have double layer parentheses. No, I'm okay with doing that. Well, but then
A divided by parentheses
3 plus x, right? And in this case, I could potentially leave those two things off, right? There's always more than one correct way of doing an algebraic expression. However, there are lots of incorrect ways, right? If we did that, that's not going to work. So this divided by that, you would put both expressions in parentheses in order to force this evaluation to be done first, this evaluation to be done next, and then for the division to happen. So 6b, 6 times b. 3, 12, 3 times 12. 4xy, 4 times x times y. So operations are performed between operands of the same type. If they're not of the same type, C++ will convert one to the type of the other. So if you multiply or if you add an int to a float, that int gets converted to a float before the addition happens. Just because the computer requires that to be the case, because integers are stored in a completely different format in memory than floating point numbers. Integers are whole numbers. The storage mechanism for that, the format for them is very simple. Floating point numbers are stored in an IEEE-based specified format that has a mantissa, the number, and then the exponent, right? So 3 times 10 to the negative 2 or whatever like that, where 3 is the mantissa and the negative 2 is the exponent. So fundamentally, the computer cannot do math on integers and floats, so they have to be converted to the same data type. The int will be converted to a float before that happens. So the hierarchy, a long double being the biggest possible value, the int being the smallest possible value, which is not really true because bytes are smaller still. Type coercion is the automatic conversion of an operand to a data type. Promotion is when it gets converted to a higher type. Demotion is when it gets converted to a lower type. I can't think of a time when demotion happens. As far as I know, it's always promotion unless you force demotion. You can force demotion by doing, well, are sometimes when it's implicit, but you can do casting to control it. And so I believe this is the chapter that talks about casting. Yeah, let me go back to where it was. So putting this into some kind of context, if you do C out 1 divided by 2.0, the 1 is promoted from an int to a float before the division happens. When the operands of a binary operator are not of the same data type, the one of the data types will be promoted to match the other data type. Ints will convert to longs, longs. Floats will convert to doubles if need be. Ints will also convert to doubles if need be. Longs will also convert to doubles if need be. That's why they set up a little chart here. Just know that double is the king of the hill. And then there are floats, and then there are longs, and then there are ints. These can hold the largest values. Ints hold the smallest values. Anything smaller than an int, like a character or a byte, will be promoted to an int. Pardon me?
Are you recording?
I so hope so. Yes.
Okay.
Thank you for saying that. You get the brownie points today. Okay. So, that is automatic or implied promotion. I'm not sure if that's the exact type that they use, but you can also force demotion if you want. If you have a double and you want to store it in an int, you can do that. You could do x is equal to, well, let's declare some variables. Double D is equal to 3, you know, exponent 100, something like that. And then you wanted to store that into a long. Long L is equal to, and you do it one of three ways. There are three syntaxes, just because C++ is such an old language that the standards migrate over time. That's one way to do it. You say, okay, Mr. Double here, I want you, I forgot, in this language you call it a long. There you're right. This is so stupid. I'm going to try to store it in an int instead, but it wouldn't fit into an int. Let's make this a smaller number. Okay. D is a double. It can't be stored into an int. You can force it to fit into an int. Now, honestly, C++ would do the conversion for you. But I'm showing this to you because if you go on and take other languages that are not as loosey-goosey with respect to type conversion as C++, you have to follow this syntax, specifically Java. And I'm hoping that all of y'all will also take a Java course. Java is an awesome language. It lends itself towards making graphical user interfaces much more quickly than C++ does. I don't even think we're going to do any graphical user interface programming in this class, but you certainly would get to in Java. End of sales pitch. Okay, so that's called casting. Casting, it's like casting iron, right? You have molten iron, and you put it in a cast, and you get your nice, teapot or whatever you're making out of it. So there are three syntaxes for casting. That's one. Another one is to do this. This is the way you did it in Python. Let's list all three ways. And then there's the third one, which looks funny. I think that's the syntax. Let me go get it. It's so perverse that I usually don't remember it. We'll get back to overflow and underflow in just a second. Typecasting. Yep. All three of those syntaxes do the exact same thing. They take this value, they run it through a conversion of specified by that to turn it into that kind of data. So you can take a floating point number and convert it into an int. You could do vice versa if you wanted to. You could take, a long and convert it into a float. Rather than rely on C++'s implicit casting, I would go ahead and do it. If you think that, if you're not absolutely sure that the result of an operation, or you don't know what both operands are, it's totally okay to convert one to the other in order to get it to function. So like if you were going to do this, C out, x divided by y, and you were worried that that was going to get rounded down because you weren't sure of what the data types were, you can convert them both to floats. C out float x divided by float y. ENDL, right? Then you don't have to sweat knowing the data types of x and y. You have converted them to floats, so you're going to get, 0.5 or whatever, rather than have it rounded down to 0. So, prof's recommendations. Use casting to convert your operands whenever there is any doubt. It's better to do the casting and not, what's the old saying? Better to have it and not want it than to want it and not have it. So I'm going to put a comment here. What if x and y are ints? The result would be rounded down. If you don't want that, use casting. Why is that important? Well, what if you did this? What if you calculate the sum of a series of numbers, and so the sum is equal to 20 when you're all done, the count is equal to, 6 or whatever like that, and then you wanted to calculate the average. Average is equal to sum divided by count. Well, if these were both ints, it's going to be rounded down. You may not want your average rounded down. Usually you like to know your average, down to the decimal point, right? So you go, okay, I'm going to fix that. I'm going to stick that make that a double. Well, you still get the same result. It's still rounded down. The average of, if that's the sum and that's the count, would still be exactly 3 as far as it was concerned. Why? Because that's an integer. That's an integer. You're dividing an integer by an integer. It performs integer division. It rounds it down, and then it stores it in there. It's not like it looks ahead and goes, oh, well, since we're going to be storing it in a floating point type, I can go ahead and do floating point math. No. So instead, you would want to do it like that. Or change one of these to a double before you do it. So all it would really take to get that to actually work would be to do some casting there. I'm just going to copy and paste that line. So this is bad because rounds down. Good because it doesn't. All right, this is something that you'll see. When people declare variables and then they want to assign values to them, you can assign them all in one fell swoop. I don't really see people do this though. But if you do int x, comma, y, comma, z, and then you want to initialize them all to 0, you can do x is equal to y is equal to z. That's kind of a big whoop in my mind, but you see people do it. The other thing you could do is this. Int x is equal to 0, y is equal to 0, z is equal to 0. They do the same thing. Whichever way you would like to do it is fine. And so this is showing the associativity of the assignment operator. The first thing that happens is 5 gets copied into z. And then the result of that, which is 5, gets copied into y. And then the result of that, which is also 5, gets copied into x. So you can do what's known as a compound operator. This is calling it a combined assignment. Other textbooks call it a compound operation. Nope, scrap that. This is a combined assignment where equal is being used to store the result of an increment, but then you can do plus equals or divided by, whatever. So x is equal to x plus 10. Just write that as x plus equals 10. You Python guys are familiar with that. X equals x plus 1, you could rewrite as x plus equals 1, or x plus plus. Y equals y minus 1. I see a hand raised, uno momento. Y minus equals 1. Y minus minus. All three of those are equivalent. This is called the increment operator. This is called the decrement operator. You didn't have those in Python. This is a compound operator, the addition equal operator. This is a compound operator, meaning that it does two things, right? It does an addition and it returns the result. Yes?
You've talked about this part before.
Really?
You went off script.
I went off script. Okay. Well, I do that. Thank you for reminding me. Okay. So you could do that. I ought to not keep talking once you raise your hand because you're trying to save me time. I've learned my lesson. Alrighty, formatting output. This is annoyingly complex compared to how you do it in other languages. You Python guys have done this. You know, print A is equal to %D, you know, like that. Right? And that, if you wanted it formatted to do 2 decimal places, you did this. That is Python. That works. Java would be very similar. System.out.printf A is equal to %. It shouldn't have been D though, I'm sorry. It's a floating point value. But I don't mind making that mistake because you can't do it that way in C++. What this is a formatting string. This says I want to print a floating point value and I want it to be 2 decimals precise. So it would print out, you know, if temperature was equal to 0.123, it would print out 0.12. And that's a really handy way of doing it. And this language doesn't give us the ability to do that with the I/O streams. The I/O streams are kind of unique to C++, and they have their quirks. So you got to learn them, but then you're going to wind up not using them that often because you're not going to wind up writing that many console applications. Instead, you're going to be writing graphical user interface applications or whatever. And then when you go onto another language, you're not going to be using arrows like in Python or Java or JavaScript or C#. Any number of languages. Hundreds of languages do not support I/O streams. One of them does. Okay, so what if you wanted to print out a nice little table? And I would like everybody to type this in, where all the values were the same length, to make it look pretty. I would need a while loop for this. So I'm going to make a while loop. Even if we haven't talked about while loops yet, we're going to do one. So remember when I said get your boilerplate ready? You can keep all this stuff here, but I'm going to delete it for the folks who haven't got it. Just know, you know, don't delete it if you already have it all working. Just put this code underneath what you already have. Let's declare a counter. But I'm going to make it a float or a doubles so that the integer division that I'm about to do doesn't mess up. And then while our counter is less than or equal to 10, I want to print out our counter divided by 3 for whatever purposes. And I'm going to put parentheses here just to force that math to happen before anything else. Followed by an ENDL. Now when this runs, it ought to print out, you know, 10 numbers divided by 3. And it's going to run forever. What did I forget? I forgot to increment or decrement the counter. So I forgot to change it so that at some point this would no longer be true. I skipped overflow because I went straight to casting and I meant to go back to overflow. I'll do that in a minute. Alrighty, so that's great and all, but what if we wanted it to all of those numbers? What if we wanted those numbers to be just rounded off to 2 digits? We got to do something in order to get that to happen. We can control the size of the output. We can control the precision. It says position. That means whether it's left or right justified. The number of digits, like the number of the places of precision, the number of places after the decimal point. But to do that, you have to have the IO_manip header file. So you're going to have to do #IO_manip up at the top. And then you can set the width of what you're going to print. You can say, I have a piece of data that I want to occupy 10 spaces on the screen. And pad it out with spaces if there's not enough, if it's not that wide. Let's play with that. So let's go back up to the top and do #include IO_manip. So before I print that number out, I need to use one more stream command, cout. I'm going to change this line to SetW 5, but that's not going to really do the trick. That's not going to actually do what we want. It's a worthy effort, but it's not going to do what we want. But let's see what it did do. Oh, these are where'd those come from? Those are pretty weird looking. They're of a different length than that. Anyways, what we're seeing,
Whole numbers are always in the 5th spot.
it seems to be displaying it to 5 digits of precision, but this is actually 6 digits of precision, and then after that it's 5 digits of precision. I'm not understanding why it's doing that.
Whole numbers are in the 5th spot.
Right, the whole numbers are formatted correct. Oh, okay. This is kind of like a hint. Please format my output to be 5 characters wide, but oh, by the way, if it's too large to fit in it, it's not going to round it down to fit into the... So this is the minimum width. That's the way to think of it. Pad out your data to be 5 characters wide. If it's smaller than 5 characters wide, great, it's going to space it out to 5 characters wide. But that didn't do what we wanted it to do here. It didn't set the precision. I'm going to write another one that kind of actually demonstrates what I wanted to see there in the first place. Let's reset our counter equal to 0. Then let's do while our counter is less than or equal to 10,000. Let's output the value of the counter. And let's do something that's going to make the value get larger pretty quickly. Counter equals counter POW counter to the power of 2. Or how about just counter times counter? That's going to get pretty large pretty quickly. Because it's going to go, no it's not, 0 times 0 is 0, right? It's going to always be equal to 0. Let's start it at 2. So it'll print 2, 4, 8, 16, 32, 64, whatever. Let's prove that that's actually what it does. Well, I wasn't expecting it to stop at 256, but I guess 256 squared is probably less than 10,000. Let's set it equal to 100,000, a million. All right. For Pete's sake.
That's minutes on my flips.
I want something that doesn't increase quite that large. How about times 2? It's actually what I meant. Just double it each time. So I just changed that line to times 2. And so it got to 500,000, and then the next time it doubled, it was more than that. Now let's say that we wanted this to have some extra text behind it. I don't know what, but I'm going to change this to put chickens, microbes. Our number of microbes are doubling every iteration. And I added that on for a reason, so that we will see that it's not all lined up. Right? 2 microbes, 4. Let's make it so that, what's our largest value? Potentially 1 million, which is 7 digits wide. Let's set the width of our number to 7 digits wide. So I'm going to modify this so SetW 7, just like that. This is what I just added right there. And there we go. Much nicer looking little table. Now, do you really need the word microbes, repeated like that over and over? But no. But it's illustrating the point. Set width controls how wide it is, but it's a minimum. If for some reason your value, change that to like a 4. It's not going to look good, but it'll prove a point. Let me show you what that point is, because I'm going to change it back to a 7 in just a minute. You see, it occupied 4 spaces until it got too large. It couldn't fit in 4 anymore. What's it supposed to do? So it went ahead and filled up 5 spaces and 6 spaces and so on. So you have to make sure that that set W is actually equivalent to the largest number of spaces that you really need. Something to notice about that is that it is right justified. If you want it left justified, you can control that. Sometimes we tend to like numbers to be lined up like that, but we tend to like words to be left justified. And if you're using Excel, Excel does that automatically. If you have a list of months down the side, it's going to left justify them. They're all going to be lined up on the left side. And if you have numbers, they're all going to be right justified, just because that's how humans like to see it. So there may be times when you want to left justify it. There's a way to do that. Now back to this stuff. We want to find out how to limit it to 2 decimal places. I don't need to know 0.3333 out to, that many decimal places. I just need 2 decimal places. I'm going to go and modify this code up here to use a different I/O manipulator. SetW is an I/O manipulator. Let's I/O manipulators control the formatting of that streams. For example, SetW sets the minimum width. You have to call SetW in front of every variable that you want to be set to that width, right? Because you can't just call it once and then everything after that is going to be set to the same width. You will get very frustrated pretty quickly if that was the case, although sometimes you wish that you could call it just once. You have to specify the width every single time. Let's put that as a comment. You have to call SetW before every value to be formatted to that width. Spoiler alert, that's a quiz question. Okay. There's another one, which sets the precision, which is the number of decimal places you have. Fixed forces it to use decimal notation rather than exponents. Floating points will display as exponents after a certain point, but sometimes you want it to always be in a decimal format, especially when you're trying to use SetPrecision. So if you use SetPrecision, it will specify the number of digits after the decimal point. If you didn't use fixed, though, it specifies the total number of significant digits. And if you've taken a physics or chemistry class, you understand what significant digits are. I'm not going to lecture on that, but I do want you to know that if you want to specify the number of places after the decimal point, you're going to want to use both fixed and SetPrecision to get it to work. Show point causes it to always print the decimal points. That may be valuable as well. Let's find out. So our first little loop up here, we want to set the precision. We want it to display. We want them to be fixed. In other words, always print in decimal format. And we want the precision to be set to 2 places after the decimal point. Fixed to display as decimal. Display 2 places after the decimal point. That's what that means. And I know we're using loops before the official chapter on loops, but just think of how fast that'll go. We get to go through them as long as you remind me and don't let me lecture too much on it. No, that one I actually remember. Okay, so now when it runs, the output ought to look a little bit better. There we go. Right. Our little values of 3, 3, 6, and 1, 1 and 1/3, 1 and 2/3, 2, 2 and 1/3, 2 and 2/3, like that. Now they are formatted nicely. This last one here, whoops, not there. Show point. I'm not sure why it's necessary because it seems to always be printing the decimal anyways, even for the numbers that ended in 0.0, like 1.00. So I usually don't teach that and I don't ask it on an exam. But if you ever find a number that's not showing decimal places and you wished it did, just keep tucked away in the back of your brain. Oh, there's another IO manipulator. So SetW is a good one. Fixed. All floating point value or forces decimal notation rather than exponent. This will be the last thing we cover. Then we'll look at our next homework assignment. And SetPrecision sets the number of digits after the decimal point. If fixed has been used. If fixed has not been used, it instead specifies the precision of the number. Alrighty, so examples. You could set width to 3 or set width to 30 and then print out Joe. And okay, 30 was a bit much. And it would print out, but I'm going to use underscores to represent spaces. It would print out Joe like that. That's not the real output, right? You understand what I said when I said the underscores. I just can't show, See out that. See out fixed. SetPrecision. 2. All the floating numbers after this will be formatted to 2 decimal places. You can mix those. You can set both the width and the precision, but remember that set width has to be called every time you want to set the width, whereas these fixed and SetPrecision only have to be used once to control all following output. Unlike SetWidth. All right, we really didn't have very much to type in, but I'd like to go ahead and make a Dropbox for that. Let's go look at the potential homework. A compound interest calculator. Whenever I've tried to calculate compound interest using loops, even though conceptually I think I understand the idea, I never get the right answer. Fortunately, accountants and mathematicians know how to calculate compound interest using a formula. And you know what compound interest is. You have, you know, an investment of $10,000 and it accumulates 0.05% interest, you know, and you calculate that for 10 years. What is your total amount going to be? So you're going to write a compound interest calculator. I used to have a really long, complicated page for this, and it looks like I've shortened it considerably. You're going to ask the user for their initial deposit. I don't know why this is deposition. You're going to ask for the interest rate expressed as a fraction. You might tell them that because otherwise they're going to type in 2% and the percent sign is going to cause the program to not work. And then you ask for the number of years. Then, if you assume that the money is compounded on a monthly basis, this is the formula. The 12 represents the months. So if you wanted to do it 2 times a year, you would change this 12 to 2. But, you know, most of us, if we're lucky enough to have accounts that earn interest, yeah, right. Used to be that checking used to earn interest. Anyways, that is the formula. The final amount is equal to the initial deposit times that. So, your program is supposed to ask the user for these 3 variables. You better use floating point for them. Although you could probably get away with using years as a whole number, I would just use a double for absolutely everything. Run that calculation, then display the result. Hopefully that one's not too hard. I'm going to revise it so that it actually has the right homework number on it and so that it says deposit rather than deposition. Maybe those terms are supposed to be synonymous. Does that make sense? Hopefully not too. It does not involve I/O manipulators, but it's a worthy little homework assignment, I think. We'll probably have another one given on Thursday as well because this is not a big challenge, in my opinion. But if you do get stuck, let me know. Make a Dropbox. Since we're done with Chapter 2, you'd want to do the quiz for Chapter 2. Does it have a due date? Is it open? Let's go eyeball it.
I think the due date was like
Last week.
it was sometime this week.
Yeah, let's fix that. Oh, wait, we did that one in class. Okay, yeah. I'll reopen it, though, so you can retake it, because I know that some people miss that date. I'm just going to remove the due date. It's on your own conscience as to whether you redo it or not.
What if we've already done it again?
Let's raise the minimum to 3 times then. I could make it unlimited. Don't take it more than 4 times or 5 times. All right. Okay. So we're in quiz 3. It's always available. If you're working ahead, reading ahead, you can take it early. The quizzes concentrate mostly what's on the book, because how could I predict in advance what extraneous topics I'm going to cover? Okay, so where was it going? Oh yeah, Dropbox. D.
You want us to turn the stuff we typed in class today?
That's what we're going to do in the Dropbox D. Yeah, thanks.
Mine.
If you did the stuff with casting, great, okay. And thresholds. Those are the things we covered. I will upload the code for the thresholds, so even if you didn't type it in, I would look at it carefully. Yeah, I figured as much. Okay. So if you refresh your Dropbox, you should see Dropbox D. Go ahead and give me
I can't get this one to run.
your code. All right, I'll be right over there. I'm going to stop the recording now. Any questions? Homework was clear enough? We have 15 minutes before I have to run out to the next class, so I can help you with typos.